math video.
What a surprise.
I know. Hey, what can I say? It's what I like to do all day, you know. Anyway, welcome, my friends, to, it looks like review 2 of Chapter 3. This is 4th grade.
Fourth graders rock.
Yes, you guys do. And look at here, we have Indy. He's back. Hey, Indy, what's up, dude? Okay, you're hissing away, huh? I see. Be really cool if we could really get a real snake sound, make you come to life. Woo! No, maybe not. Actually, you know what? You guys are pretty venomous snakes. Yeah, even though I know you don't really go after adults, you know, we're kind of scared of you when you do that whole lift up your hood thing. But anyway, great to have you here. And let's get down to business. It says that Jess made this model to find the product 32 times 17. It says her model is incorrect.
Uh-oh.
Well, okay, we'll take a look at her model. Well, what I see here. Well, with our area model, the way this works is basically we're taking 30 and we're going to multiply it by the 10 of the 17 and also the 7 of the 17. And 30 times 10 should be 300. We only have 40 there. Okay, that doesn't look right. Oh, you know what? I can see what you did.
Hello, Mr. Warrior, kind of slow.
I know, I'm a slow thinker. I'm deep, though. She just added, she didn't multiply, you know? Hey, 30 plus 10 is 40. 30 plus 7 equals 37. No, you know what her mistake was? She added instead of multiplied. So let's go ahead and write those notes down. Yeah, let's use Indy's colors. So we have Jess made the mistake of adding instead of multiplying in her model. Woohoo! Yeah. Okay, are we cool with that, Indy, huh? You like my colors? Yeah? Alright. You know what? We're going to use just Indy colors in this video, okay? Just because
Mr. Warrior's weird.
Just because I'm trying to be nice to this guy. Come on, you don't want him to bite me. I mean, I want to survive the video. I want to be able to make new videos. And, you know, this guy is one of the top 4 dangerous cobras in the world. Okay, let's move on to part B. It says redraw the model so that it is correct. Okay, so I'm going to go ahead and put my problem up here again. 32 times 17. So here I have 30, and I always like to put my little plus here. You don't have to. I just do that so you're reminded of the fact that it's not the number 32 has been decomposed, broken apart, if you will, into 2 place value. Like we have 30 and we have 2, 30 plus 2. And then up here we're going to have our 10. And of course we're going to have our little plus sign if you wish to add. And then 7. So it kind of lets you know what we have to do here. Key point. Maybe you want to put this right in the corner here. But we're going to multiply. We're not going to add. So 30 times 10 is 300. I'm getting ahead of myself.
Slow down, Mr. Warrior. Calm down.
Yes, I shall be calm. 30 times 7 is 210 because I know my simple fact is just 3 times 7, which is 21. And then I add on my power of 10. Don't complicate this. 2 times 10, super easy, is just 20. And then, of course, 7 times 2 equals 14. I like it. Now, I can add up all my partial products. Remember we talked about partial products. 300 plus 210 plus 20 plus 14. And you can see we add them together. We get 4. We get 3 plus 1 is 4. And then 3 plus 2 is 5. So I get 544. This is using the area model. This is how we can prove that 32 times 17 is indeed 544. However, it's very easy to make a mistake even with the actual area model. So I can go ahead and do the standard algorithm. And I know that my students, oh my goodness, they actually need a lot of help with this standard algorithm. Because the truth be told, this is just my
Personal opinion.
But you know, soon, this is 4th grade math. But by the time you get into 6th grade, 7th grade, maybe you're going to start using a calculator a lot more often. And I don't know if this algorithm is going to be near as important as it is when you get up into middle school and high school. What is important though, however, is that you understand this model here, that this makes sense to you. Okay, the people who get up in the higher level math, they're able to explain why certain things are the way they are. Anyway, sorry, I just had to get in my 2 cents. But this is how we do the basic algorithm. And sometimes, I don't know, maybe drawing a line between the two will help you. But this is key because digits need to stay aligned, because this has to do with place value. So if we're going to multiply a 7 and a 2, we need to make sure it stays in that ones column. We can't have it going in the tens or it's going to change our answer. Well, of course, 7 times 2 is 14. That's 4 down there. I carry my 1. Now I'm going to take my 7 times 30. There's a 3 actually over there. And here I get 21. If I just multiply the 2 plus 1 is 22. And so I'm going to get a 2. So it's really what I'm saying is I have 22 tens. That's really what that says right there. Don't worry though, we're going to be good. You'll see. Then I'm going to go ahead and put in my placeholder. The main reason I'm putting in that placeholder is because I'm going over here to the tens column. So that means that I want to make sure that I don't accidentally put my digit here in the ones. 2 times 1 is 2, so that just gives me 2 tens. And then of course here I have 3 times 1, which is 3. Now, you can separate this too if you want. You don't have to. I'm just doing this to show you that that's the 10 columns and that's the hundreds. But they're all aligned. That's most important. Now we have 4. Now we have 4. And 2 plus 3 is 5. And look at that. Oh, yes. So pretty, pretty, pretty. Yes, it's 544. Woohoo! Yeah, yeah. Now we move to the bottom problem here on page 137, number 9. It says Tatum wants to use partial products to find 15 times 32. Write the numbers in the boxes to show 15 times 32. I might be able to do that. Let's get started. Looking at this, I can see where some people will be kind of confused. I have 2 factors that need to be in these parentheses here, plus 2 more factors in another set of parentheses, plus 2 more factors in parentheses, plus, oh my goodness. Oh, I see. So it's almost like we're saying, look, we need to multiply the 10 from the 15. We need to multiply that 10 with the 30 and also the 10 with the 2. Then we need to multiply the 5 with the 30. Ooh, look at that. And then the 5 with the 2. Look at.
Was that accurate or what?
No. Okay, so let's do that. So we're saying then we would have 10 times the 30. Then we're going to have the 10 times the 2. Now I'm going to go to the 5 times the 30. And of course the 5 times the 2. Woohoo! Yeah, yeah. I'd say we completed this page. I think it's time for Page Master. Ooh, yeah. Oh, yeah. Look at Indy's back. Cool Indy. He's bad, huh? Bad, but like in a good way. I'm going to go ahead. Please relax. I'm just trying to fix your little tongue there. Just trying to make it a little darker. There you go. Oh, look at that, huh? Tell me I didn't help you out, buddy. Yeah. I'm your friend, remember? Okay? You ever see me out there?
Yeah, just slither right by Mr. Wara. Please don't attack.
That's right. Okay, number 10 says, which product is shown by the model? Write the letter of the product on the line below the model. Okay, I think I understand. We have A. Oh, we have a 17 times 36. Okay, so this is kind of easy because it's like multiple choice. You got 3 possible answers here. Well, remember how I always said on my little models, I always put that little multiply there, okay? And I kind of always put my little plus sign there. All right, so I'm still using brown. That's cool. So here I have 10 times 10, which was 100. And here that means that 10 times, I would have to have a 10 there, 2 there, but I don't. Here I have 2 times 10, but I'm looking for 10 times 10. Look at that. That's C right there, the very first one. Let's double check, make sure we have a 3 times the 10 we do. Do we have 3? Aha. Oh, look at the numbers are identical, so of course it's going to just be the opposite. The 3 times the 10 rather than 10 times the 3, 3 times the 10, and then 3 times 3, which is 9. So this is definitely C. So I'm going to write 13 times 13 and that blank right below. I come up here, I have a 10, so now we know you're out of the running now. So now we have 10 times 30. Well, look at this was 2 times 10. This is 10 times 30. Must be this one. 7 times 30? Yeah. 3 times, where do we have this one? Oh, 30. I'm sorry. 30 times 10? Yes. And then 6 times 10? Yes. 6 times 7? It's all there. I'm all over the place. But you know what? That is it for sure. So we're going to put 17 times 36. And that must mean the last one has to go over here. Is it true? 10 times 20 Yep. And then I also have 10 times 4. Yep. 4 times. Yep. It's all there. Woohoo! Yeah, yeah. So I'm going to put my 24 times. Oh, no. What happened? It's probably because Indy was hissing on it. Made it blow away. You're so tough, dude. Yeah. We're friends.
Remember, we're friends. Yes.
Okay. Indy, the Indian Cobra. Okay, and then 11 we have Mrs. Jones places 3 orders for school t-shirts. Each order has 16 boxes of the shirts, and each box holds 17 shirts. How many t-shirts does Mrs. Jones order? Use partial products to help you. All right, so if I was scoring this test, teacher, this would have to be part of your notes. If you didn't have that, I might take a couple points off. Yeah, because it's telling us to use partial products. So let's go ahead and do that. 3 orders for school t-shirts, right? Each order has 16 boxes of shirts in each box, and each box holds 17 shirts. Wow, but this is going to be like a mega problem. Okay, so the problem I see here is I really see if you have 16 boxes and 17 shirts, so you're really saying I'm taking 16 boxes, and I'm just going to write this equation out first to help me understand. We're going to take 16 boxes, we're going to multiply that by 17 shirts in each box. Okay, we could try to add them all up. We could go 16 plus 16 plus 16 plus 16 plus 16, right? All the way. It would take forever. That's why they made up this thing called multiplication. So 16 boxes times 17 shirts makes that easier. But we have 3 orders. See that? It's not just this one order. We have 3 orders of that amount. It says each order has that much. So actually we're taking this and we're also multiplying it by 3. Wow, heavy duty. Well, I'm going to use my partial products here. I'm going to go ahead and draw myself an area model. It's going to be all squiggly like because, my pen tablet, it's just that way. Oh, I could have put it in a box, but you know what? I want it to be natural. So here I'm going to put something down here in the middle here. That's really crooked, isn't it? It's okay. It's okay, Mr. Wara. Oh, no, now I can't deal with it. Have to fix it. There you go. There you go. I completely cheated. That's right. I used my software. Okay, so I'm going to put my times sign up there. Here I'm going to have 10 plus, remember I have 6 because that makes 16. And then up here I have 17. So that means I have 10 plus my 7. All right, so 10 times 10, easy peasy. Yep, 100. And then, of course, 10 times 7 is 70. Now I come to this one. 6 times 10, it's lined up with that, is 60. And then I have 6 times 7, which is 42. Okay, so this may help me, I guess. Okay, yes, it will help me. Of course it's going to help me because now I can just say 100 plus 70 plus 60 plus 42. Add them all together. I get 2. Now I have 10, and then that's 17. Carry the 1. So I end up with 272. So this here, I could actually draw and say that that's 272. That's just one order. That's a lot of shirts. Now I have 3 orders. So I'm going to multiply that by 3. So for this one here, I'm just going to use a standard algorithm. But first, I don't know, I feel like I don't have any more room. I don't want to be like moving into this area of the problem. So I'm going to go ahead and do my shrinky thingy. Okay, let's get you to shrink. Shrink! Ah! Okay, I hope you have those notes. I'm just going to push them off to the side. Thank you very much, smart software. Now let's go ahead and take our 272 and we're going to go ahead and multiply it by 3. Now 2 times 3 is 6. I keep moving over. 7 times 3 is 21. I put my 1 down. Remember, I carry my 2. So you always make sure that that digit farthest to the right is the one that you put down, which is this is your 1's place. Now I have my 3 times 2, which is really 200 times 3. And then I also have 2 up above. So I actually have 6 plus 2 plus 6 plus 2 is 8. So I get 816. My question is that reasonable? 272 is almost 300. If I round it up, that would be 300. 300 times 3 would be 900. And 250 times 3 is 750. It's right in between those two. So I'm going to say yes, final answer. And keep in mind, I don't think you had to do the area model. Partial products means you could have also actually just said, you know what, I'm just going to take my 10 from the 16, multiply that by the other 10, plus, again, take the 6 from the 16, multiply it with the 10, and then we're just adding. We get 2 more partial products. Now that we've done those two, now I need to take 10 times the 7 plus 6 times the 7. This is how we got our partial products. And that still would have given you that 272. And then we would have multiplied by 3. Okay? Anyways, write the unknown digits. It says use each digit exactly once. Ooh, okay. Well, we have 5 digits there and we have 5 open spaces. Okay. I guess we're doing like a standard algorithm here. Or not. Ooh, or not. I see 1, 2, 3, 4 partial products here. And with these 2 zeros here, that's going to throw me off. So I see here 40, if you did do that, 40 times 90. 4 times 9. Aha. They're both in the tens place. It's going to give you 3,600. So a 6 is going to go here. At least that's what I think. And then here we get into 500. So if you did that one, maybe that is 6 times 90. There it is. 9 times 6 is 54. That's 540. Yes, that's that one. And then here, that was probably my 120. 40 times 3 is 120. So the 1 must go here. Yeah. Then the last one, just the ones, is going to be the 18. And did it work out? Yeah. Did I use the 2 already? Oh, no. 2 comes down here. Because we have to add them. So this should be way over here. This box looks like it's under the tens place. Ooh. Error alert. Error alert. In my opinion. Should be a little bit over. So that gives us our 8. Then our 1. Yeah, it's not lined up with the hundreds place. It's a 10. So that's 3 plus 4 is 7. So that's 7. Got it. So now we move over into the hundreds column, which you're not even 100. You are. There's 1. There's 6. And then another 6. So that's 12. Carry the 1. And then you can see how that becomes the 4. Yes. Okay. So there's your 2. We used them all. Ooh. That was a workout. Whew. Do we have more? We do, and there's Indy again, down at the bottom. Yay! Hey, where'd you go, Indy? Come on back. Did you do that? That was pretty sneaky. Anyway, 13 says, Mike has 16 baseball cards. And it says Nico has 17 times as many baseball cards as Mike does. Ooh, key words there. 17 times. Yes, 16? Yes, 17 times. Whenever I see this, can't help but think that's exactly what it says. How many baseball cards does Nico have? Oh, he's got that many, 17 times his amount. So we have 17 times 16. Now, it doesn't say anything about doing partial products, so I'm going to go ahead and do the standard algorithm. 7 times 6 is 42. I put my 2 down here. I carry my 4. Remember, the 4 is going to get added later. Okay? Now we have 6 times 1, which is 6. 6 plus 4, which is 10. So I get my 10. Remember, I have to put in my placeholder. That's right, you have to get that placeholder in there because now we're moving into the tens column. 1 times 7 is 7. 1 times 1 is 1. Now we just simply add them together. We get 2, we get 7. 272. Boy, why does that number sound so familiar? That's what we had up above. So I'm going to say it's 272 baseball cards. That's how many cards Nico has. I just love it when things work out. Okay, now it says multiply. Ooh, look at that. It's important that when I'm multiplying, that I line up digits. Here I have 6 times 8, which is 48. So I put my 8 down here. I carry my 4. The 4 will be added. 8 times 3 is 24, plus 4 is 28. So I put my 28 down here. So now I'm moving over. I did the 8 times the 6 and the 8 times the 3. So now I have to put in my placeholder. That's right. And then I come over and I'm like, okay, 6 times 2 is 12. All right. And I carry my 1. And this is 3 times 2, which is 6, plus 1, which is 7. All right. Now I'm adding again. Getting 8, 10, carry the 1. I get 7 plus 2 is 9, plus 1, which is 10. So I get 1,008. Now you could, ooh, that's kind of a sloppy little 8 there. Hope you can tell what that is. Yeah. You could actually write 1,008 that way, or you can put in the comma. Either way is good. Cool. Looks like this is like into another video, right? I think that we're, what? Oh. What? Oh, okay. I guess Indy has something personal he wants to say. All right. He says I got to check the next page here. I guess he's... Yes, I do. Okay. So, it's clear he wants a little respect. Dude, I'm telling you. I totally respect you, man. Okay? I would never, ever hurt you in any way. You have a right to be here on this planet just like the rest of us, okay? Okay. Yes? Oh, really? You're calling the shots now? You're going to tell my crew when to actually put the... Oh, man. I can't believe.
My crew, you're listening to the snake over me?
Okay, this is a little much. I run the show here. I mean, well, Indy, you have a certain role here. Help! My show's being taken over by a Indian cobra. Help! Hey, you guys. Hey, great being with you. Thank you for being able to deal with all my silly humor. Now, like I always say,